In this video, you will learn how to find a good viewing window with the aid of the table. This is probably one of the most difficult things you will do when using the calculator, but with practice and an understanding of how the functions behave within the domain and range, this process will eventually become easier and easier. So for the first example, we would like to find the graph of y equals negative 2x cubed plus 12x squared plus 19x minus 9, and then find an appropriate viewing window for this function. So let's first input the function, and that's going to be negative 2x cubed plus 12x squared plus 19x subtract 9. And let's make sure we're in the standard viewing window, so we go to Zoom, and then Z standard is the standard viewing window, so we hit number 6, and now it's going to graph this function in the standard window. Okay, now we know that this is a cubic function, so you should have an idea of what the basic cubic function looks like. That is, y equals x cubed, and that graph is shown directly to the right. So what's happening here then is that the function is coming down, and it goes down and reaches some minimum and then comes back up, and it crosses the x-axis here, and then it goes up, and then it hits some maximum, and then it comes back down, and then it keeps going down. So one thing that we can notice is that between 0 and let's say 8, there is a maximum. It's going to reach some peak, so it's an increase, and then it hits a maximum, then it decreases back down. So we can figure out how high we need to go to view the rest of this graph. Okay, and then the other thing we notice here is that between, looks like 0 and negative 1, this function goes down and then it comes back up again. Okay, so between 0 and negative 1, we can figure out how far this function needs to go before it comes back up. So we'll be able to set our y minimum value. So let's go to the table function, but first let's just make sure our table set is set correctly. So go second function and then table set, and this is exactly the way we want it. We want the independent variable to be on ask and the dependent variable to be on auto. Okay, so let's get out of that. Second function quit, and then we'll go to the table. So second function and then table. So let's figure out what's going on between, let's say, 0 and 9. So we will insert some values for x. So let's start out with 0 and then enter, then 2 and enter, then 5 and enter, then 6 and enter, then 7 and enter, and then 9 and enter, and 15 and enter. Now let's take a look what's happening here. There are some patterns that we will notice. Between 0 and 2, notice that the function changes from a negative value to a positive value, and that's where the function will cross the x-axis. Let's just go back and take a look at that. So between 0 and 2, you can see here that it crosses the x-axis right there. Okay? Let's go back to the table. Take a look at some of these values in the table. At x is equal to 2, y is equal to 61. At x equals 5, y is equal to 136. And at x equals 6, y is equal to 105. Now, what this tells us is that somewhere between x equals 2 and x equals 6, the y value reached a maximum. What that actual maximum value is, we don't know. but is all we want to do here is just get an idea of where we can set our y max value in the window setting, so we can actually see where the maximum occurs. So let's go back to the graph. So it looks like it reached some maximum value, the peak up here somewhere, and then it started falling because it was increasing, and then it fell to decreasing. Okay, so let's go back to the table. So this tells us that somewhere between x equals 2 and 6 the maximum occurs. And then we put in 7, it went down to 26, so it's decreasing further, and then 9, it's decreasing. And in fact, between 7 and 9, it went from a positive value to a negative value, and that means that it crossed the x-axis again. Okay, so let's take a look at that, and here's where it's crossing the x-axis, right there. Okay, and then it continues to go down and down, and that's illustrated by this last number, 15. The further we go out on the x-axis, the y values become smaller and smaller, okay, which makes sense. So the maximum value is somewhere around 136, okay, and to play it safe, we will need to set our maximum value for y, let's say, to 200. So let's go into the window, and let's move down to y max, and let's input 200. And let's go ahead and change the scale to 5. And that's what the increments will be spaced by. So now let's hit graph. So the function looks a little bit better here. We could increase the increments on the y-axis, but that's okay. So here's where our function went up, and then it hit a maximum right here, and then it started decreasing again. Pretty much this is what the function looks like, so all we really need to do now is just show a little bit more of this function further down on the y-axis. Okay, so all we need to do is decrease the y minimum value. So let's go to Window, and let's change the y minimum to, let's say, negative 50. That should be fine. And let's hit graph. Okay, and let's just do one more thing. Let's change the scale here. These are kind of cramped together, these increments. So let's go back to Window, and let's change the y scale to 10. And let's graph that. Yeah, it looks a little bit better. So that's a good viewing window. Now you could change it a little bit, the viewing window. You can go a little bit higher or a little bit lower. But basically you'll get to see what's going on with this function. Where the minimum is, where it hits the x-axis here, here, and here, and you get to see the maximum. Those are some important parts of this graph. So this particular example was pretty easy. We didn't have to struggle too much to figure out what a good viewing window would be. So let's go to example 2, which is going to be a little bit more difficult. Now, let's clear out this function. Let's hit clear. And let's go back to the zoom. And we want to get it to zoom standard. So let's start here in the standard viewing window. And let's quit out of this. In the second example, we would like to find the graph of negative 1.05 raised to the x power plus 50x subtract 2500. And then we would like to find an appropriate viewing window for this function. Alright, so let's first input the function, and that is y is equal to negative 1.05 raised to the x power plus 50x subtract 2500. Okay, now this particular function here is not something that should be familiar to you. It's not a linear function. It's not a quadratic or a cubic or an absolute value or a root function. This is sort of unknown. So let's just see what happens when we hit graph. If we can get some kind of an idea. So what we have here is an empty window, which means that the graph can't be viewed in the standard window. So let's go to the table and start inputting some values. So let's go to second function and then table. And we can go ahead and start out at 0. That's always a good place to start. And then we can just overwrite these other values here. Okay, or we can delete them right now so it doesn't look too cluttered. So let's go ahead and just move the cursor down and then start hitting delete. So let's input these values. We have 0, and then let's go to 5 and then enter. Okay, so it looks like it's getting less negative here. And let's go to 20. See what happens. So it's getting less negative, so the function's actually increasing. Okay, and let's now go to, let's say, 50. And we're all the way down to negative 11, so it's getting closer to hitting the x-axis. And let's go to, let's say, 60. So this probably is going to be a positive value, and it is. There's a sign change between 50 and 60. So this means that the function is going to hit the x-axis somewhere between 50 and 60. All right? Let's go to 70. Enter. And so it's still increasing. And let's go to 100 and then hit enter. And you can see it's getting larger. So what's happening here is we go further out on the x-axis, the function starts to increase, and that's all we know right now. So let's go ahead and change the x max to, let's just go out to 100, okay? And let's change the y max to, let's say, we could put it at 4,000. That should be safe. So let's just see what happens when we do that. Okay? I'm putting it at the x max to 100 and the y max to 4,000. Okay? I'm going a little bit past this. So let's go to Window. So the x max, I said 100. And the y max 4,000. Okay, now let's graph that and see what happens. Well, at least we see something now. We see something going on. So it looks like this function could be still increasing. Well, we know it's not a linear function, so it's not going to be a straight line. So something's going to happen further out on the x-axis. I'm not sure exactly what's going to happen, but let's take a look at the table a little bit further. So let's go back into the table. So let's see. Let's start at 100. So I am going to put 100 here on top and then enter. And then I'm just going to start overwriting these values here. So let's put in 200. Let's go a little bit further out. Then enter. So from 100 to 200, it went from positive to negative. So here's another sign change. Okay? So this is telling us that between 100 and 200, the function went from a positive value, in other words, a positive value on the y-axis, down to a negative value on the y-axis. So that means it had to cross the x-axis. Okay? So that's something to keep in mind. So let's decrease this a little bit. Let's go back to 150 and see if there's a sign change. So there isn't a sign change. So from 100 to 150, it increased a little bit. Okay, so then from 150 to 200, we know it decreased in value. All right, so that tells us a story between 150 to 200. It's crossing the x-axis. All right, let's continue on with 175. See what happens. Okay, so it's decreasing here. All right, and then so between 175 to 200, we have a sign change. Okay, this means that it's going to cross the x-axis between 175 and 200. Okay, so let's increase it a little bit more. 185, enter. 200, and then enter, and then let's say 300, and enter. Okay, so this tells us a little bit of a story here. Okay, so we know that we're going to have a crossing at the x-axis between 175 to 185 because of the sign change from positive to negative. All right? Then, as we move further out, it's getting smaller and smaller, and then very small. This is negative 2.3 e to the 6th. Remember, that means times 10 to the 6th power. Okay, so that's negative 2.3 times 10 to the 6th power. That's what that e means. It means 10 to the, and then whatever that number is. So what we can do here is that we can still increase our y value to, let's say, I think 4,000 might be all right. Okay, because here's 3,500. Okay, and it doesn't get much larger than that, and we already have it set at 4,000. So we could keep it there. But what we do need to change is the x value. So let's go back to the table. Our x max looks like we can still bring it out to, let's say, 200 should be fine. That's very, very small. So let's go to 200. Okay. So let's go Window, and let's go to x max to 200. And let's graph that. See what happens. And that makes sense because from our table, we know that we were increasing and then all of a sudden it started decreasing again. Then we had a sign change over here. Now we need to figure out what's happening to this function as we move further to the left on the x-axis. So let's go back into table and let's delete all these values out. And let's again start at 0 and then enter, and then we'll input negative 10, then negative 20, then negative 50, then negative 100. So let's take a look what's happening. As we go further and further out on the x-axis with the negative integers, the outputs are getting smaller and smaller. Okay? So let's keep going and see if it still holds the same pattern. So let's try negative 200, then enter. And let's try negative 500. So that's true. So this function keeps going down further and further on the y-axis. So let's go ahead and change our x min to, let's say, negative 200. All right, so let's go to Window, And let's change this to negative 200. And then graph that. Now, what we're not seeing, obviously, is what's happening down here. Okay, this function is, decreasing further and further down. So what we need to do is, let's go back to the table, and you can see that the y values are getting smaller and smaller. So let's take it to negative 20,000. However, if you recall that our y max is set to 4,000, it is best to keep this within a good scale. So let's not go down as far on the y-axis. Let's just say we want to go down to negative 2,000. Okay, and that will keep everything in a good scale. It won't look out of proportion in the graph. Because if our y max is 4,000 and then we go all the way down to a negative 20,000 for the y min, it's going to look a little bit distorted, the graph. So it's best to, let's say, go down to negative 2,000. Let's go to Window, and so y min, and we'll set that to negative 2,000. And let's change the scale here. Let's make this every 10 units. And let's make this every 100. Okay, now let's graph this. Okay, so these are still a little bit cramped. So let's change the window. And let's go to scale. Let's make this, say, every 20. And let's make this every 200. Okay, let's graph that. That's a little bit better. So let's just verify that the further we go out in the x-axis that nothing comes back up over here. And we'll do that. Let's just go back into the table and let's start at 100. We started there before. And let's keep going out. Let's go to, let's say, 300. Enter. Let's go to 400. Then 500 and enter. Okay. And let's just delete the rest out of here so it doesn't clutter things up. And you can see that the further we go out in the x-axis, the y values are getting smaller and smaller. In fact, they're getting very small. This says minus 2.3 times 10 to the 6th, minus 3 times 10 to the 8th, and minus 4 times 10 to the 10th power. So it's very small. So if you go back into graph, what's happening then is that this function keeps decreasing and decreasing and decreasing as we go out to negative infinity, and this part over here keeps decreasing and decreasing as we go out to positive infinity. All right? So that would be an appropriate window here to view this function. Okay? And the reason why it's appropriate, it's showing a lot of the important points. Again, the maximum here, here's an x-intercept, here's an x-intercept. We could go down a little bit further and see what the y-intercept is down here. So what we're going to do is we're going to change the x scale to 25, the y min to negative 4,000, and the y scale to 500. And this should give us a very good window with all the points of interest being shown. That is the x-intercepts, the y-intercept, and the maximum value. Okay, so this would be a good viewing window here. There's the y-intercept, there's the x-intercept, there's another x-intercept, and there's the maximum right there. So this one took a little bit of effort. We had to view different values of the table and find out how far we needed to go, either to the left or right, or the up and down. And we also needed to change the scale so it doesn't look so cramped. Alright, but this is a very good viewing window. The more you do this, the faster you'll be able to work with the table and figure out exactly where you need to put your viewing window. Okay, so let's go to our last example, example number 3. So first, before we do that, let's clear everything out. So we're going to have y equals. Let's clear this function, and let's go to zoom, and then standard, and let's quit out of this. Alright, so for our third example, we would like to graph y equals negative 0.005 x to the fourth plus 0.8 x cubed minus 2x squared plus 7x minus 6,000, and then we want to find an appropriate viewing window for this function. So let's go ahead and input the function, and that is negative 0.005 x to the fourth power plus 0.8 x cubed subtract 2x squared plus 7x minus 6,000. Now let's go ahead and graph this. Notice in the upper right hand corner you see a little bit of flashing, and that indicates that the calculator is busy. Once again, notice that the function cannot be seen in the standard viewing window. So we need to do some investigation, and we do that investigation with the use of the table. So let's go ahead and start out with some simple values. Okay, so let's delete these values in the table, and let's go ahead and start out with 0, and that's our y-intercept. When x is 0, y is negative 6,000, so that's where it crosses the y-axis. Okay, so let's start inputting some more values. So then 10, 20, 40, and then enter. So what's happening here is the function is increasing because we're getting less negative, and then finally we go from negative to positive. So again, there's a sign change, negative to positive, so that means that the function crosses the x-axis somewhere between 20 and 40. So let's continue on with 50, and then 100, and let's say 200, and enter. Okay. Something interesting happened again. So remember, between 20 and 40, it crossed the x-axis. Then it kept on increasing, and then from 100 to 200, we have a sign change. Okay, so we go from positive to negative. All right. So this means that the function crosses the x-axis again between 100 and 200. All right, so let's take a look at this again, what's happening here. As we move further out on the x-axis, okay, imagine this, that the function is increasing. Okay, so it's going from the negative values of y, it's moving up, and then right here between 20 and 40, it crosses the x-axis. Okay, so it crosses the x-axis and it's continuing moving up. It's moving up, and then all of a sudden between 100 and 200, it makes a change and it's going to start going down. So we need to figure out where it's going down. It's not necessary right now, but we can go ahead and get a start on the window. So let's go on our x values from minus 10. Let's take it out to, let's say, 200, and let's go a y minimum of negative 5,000. So our window, let's go x max of 200, and let's take this y minimum, okay, Let's go to negative 5,000. Let's put it at that. And let's go ahead and set the Y scale. Okay. Let's go back here a minute. Table. See what our Y max could be. Our Y max, that looks like around 250,000. So let's go to 250,000, let's say, for our Y max. Okay. So we have our range like from minus 5,000 to 250,000, and then our X range will go from negative 10 to 200, just to start out with. All right, and let's make the scale here being, let's say, the increments being every 1,000, and this one will keep as 1. That's fine. So let's graph it and see what happens. Well, at least we see something now. So this gives us a good picture here. So remember that the function was increasing, then it hit the x-axis like we said, okay, and that was between 20 and 40, okay, and then it should hit the x-axis again between 100 and 200. So let's go back to the graph. So it goes up and then it comes down and it hits the x-axis again. So somewhere between 100 and 200, it hits the x-axis again. So it increased to its maximum, then it came down. All right. So we need to increase the y values, or increase the window on the y values a little bit higher so we can see this maximum value. So let's do that. And here we can just kind of guesstimate. Let's take it up another, let's say 100,000. Let's move it to 350,000. Okay, 350,000. And let's set the scale to 5,000. All right, so let's graph that. Let's see if that shows us the maximum. And it does. So it looks like the function is increasing, and then it hits a maximum, it decreases. So we definitely know that we need to move the scale for the y min definitely further down, okay, and we need to move the x min value to the left a little bit further. Okay, how far? Let's go ahead and look at the table again. So let's go back to second function in table, and let's start at 0, but this time we're going to use negative values for x. So let's delete all of these values to get rid of the clutter. So let's go negative 10, negative 20, negative 40, enter. So what's happening so far is these values are getting smaller and smaller. Okay, let's go negative 50, and negative 100, and negative 200. Okay, so it's getting smaller and smaller and smaller, because this is times 10 to the 5th, then negative 1.3 times 10 to the 6th, then negative 1.4 times 10 to the 7th. So the further we go out on the x-axis for the negative values, the y values become more and more negative. So let's change our window then. Let's set the x min to negative 200, and let's say the y min to negative 500,000. So let's go to Window, and let's set this to negative 200. Okay, and let's go to the y min being negative, let's say 500,000. Okay, and let's change the scale here on the x-axis, let's go every 10 units. Okay, and the scale here on the y-axis, let's change that to every 50,000. And let's graph that. So that looks like a really good viewing window right here. So you can see the function goes up, it hits the x-axis somewhere, then it increases, then it hits a maximum, then it goes down and hits the x-axis again. Now, what's going on here is really unclear. You could see that in the table. Let's go back to the table and actually check out what's happening here. So between 0 and -10, it's getting smaller and smaller. But let's just check out here between 0 and, let's say, 5. Okay, and then enter. Okay, so between 0 and +5, the function's still negative. All right? The y value is still negative. So if we look at the graph, it's actually below this line. You can't really see it. So this looks like a pretty good viewing window. We can see the x-intercept somewhere around here, and then a maximum, and then the x-intercept again, and there is some y-intercept around here. Now this is a little cramped here, so we could adjust this window a little bit better. So it doesn't look like we need all of these values of x, and maybe we could go ahead and not have so many of these negative values for y. Alright, so let's change this a little bit and see if we can get a better idea of what's going on here. Now in the next video we will learn how to use the zoom box feature, and that's an easy way to figure out what's happening in this area. So let's go to the window and let's change this a little bit. Let's not go so far, like I said, on the x-axis. So let's change that to -100. And let's not go so far down. So this says -500,000. Let's make it -50,000, let's say. Okay? And it goes to 350,000. And then each increment is going to be spaced by 50,000. So let's graph this. That should help a little bit. Okay, so you can see here this does have some y-intercept right here. Then it goes and it comes back and it hits the x-axis somewhere around here, and then it goes up to a maximum, and then it decreases back down and it hits the x-axis here. So this would be a pretty good viewing window. Alright, what we have here from -100 to 200, the scale of 10, and then -50,000 to 350,000 with a scale of 50,000. Okay, so I'd say that's a pretty good viewing window. We could tweak it a little bit more, but that gives you an idea of what exactly is happening with the function. As I mentioned before, it can be very difficult to find a good window for a particular function. You should be familiar with a lot of the basic functions, such as the linear function, the quadratic, the cubic, even and odd functions, and so on. And that will aid you in finding a good window. Also, looking at patterns in the table will help you find a good window. So notice when there are sign changes between the outputs, and also when the function is increasing and decreasing will also help you find a good window. So this concludes the video on finding a good window with the use of the table.